Good morning, students. Today we will discuss reactions of phenol. Next part of our lesson, that is reactions of phenol. Okay, reactions of phenol. Total 8 reactions are given in our syllabus. What are these reactions? First reaction, that is halogenation reaction. Listen to me carefully. Halogenation, we do here bromination of phenol. So what happens in this reaction? What's the product obtained in this reaction? Product obtained depends upon reaction condition or the solvent used to carry that reaction. So product depends upon solvent used. So solvent, it can be non-polar, or instead of non-polar we can say less polar solvent, and other one is highly polar solvent. Less polar solvents means we can use CHCl3 or we can use CCl4 or we can use CS2. And if it is polar solvent everybody knows, that is water. So what's the difference in the products obtained? As condition changes, product changes. We know that phenol is ortho-para directing. In phenol, benzene ring is attached to this OH group. Oxygen have lone pairs of electrons. So oxygen gives its electron pair to benzene ring. So ortho position and para position becomes electron rich. They get negative charge. So ortho and para directing. This OH group is ortho and para directing. So when we do reaction in presence of less polar solvents, we get mixture of ortho and para substituted phenol. And if we use water, then substitution takes place at all ortho and para positions. Means we get 2,4,6 tri-substituted phenol. See what's the change. Phenol reacts with Br2 in presence of CS2. At lower temperature this reaction is carried out. In the old syllabus they gave that temperature as 278. In your text they have given only low temperature. So Br goes to ortho position and para position. So we get here mixture of ortho-bromophenol and para-bromophenol. Obviously byproduct formed in the reaction is HBr. Here one H is there, that H and one Br. H is replaced by Br and byproduct formed is HBr. Here also one H is there, that H reacts with this Br. HBr is the byproduct formed in the reaction. Now out of these two, this is a major product because two bulky groups away from each other. In this case they are ortho with respect to each other, so there is steric hindrance and we get minor product. Is this clear? So when phenol reacts with bromine in presence of less polar solvents at lower temperature, we get mixture of ortho-bromophenol and para-bromophenol, in which para-bromophenol is major product. Okay. Now what's the product? If we use polar solvent, see what happens. Suppose we have started with phenol and it is treated with Br2. Bromination we are doing in presence of water. Polar solvent is used. As water is polar, it creates poles in this molecule. So most polar positions are both ortho and para. So both ortho and para positions get activated and these hydrogens at ortho and para are replaced by Br and we get the product as OH, Br, Br and Br. plus HBr. Balancing is not needed. If you want to do, we can write here 3Br2, 1, 2, 3, 3 hydrogen, 3 Br. So byproduct formed is 3 HBr. They are not shown balanced equation for this. Whenever major minor products are there, no need. Here we can write 3 HBr. Now what's the name of this substance? I wrote there 2,4,6 triad. See, this is main functional group, and OH and X, alcoholic group, and halogen. Higher priority is given to OH. We studied this in 11. This is carbon number 2, 3, 4, 5 and 6. So at carbon number 2, 4 and 6, 3 Br are there. So it is named as 2,4,6 tribromophenol. 2,4,6 tribromophenol is the product formed in this reaction. Clear? First reaction, that is halogenation reaction. So phenol reacts with bromine in different solvents and it gives different products. If solvent used is less polar like CS2 or CHCl3 or CCl4, then we get mixture of orthobromophenol and parabromophenol. And if we do reaction in presence of polar solvent, then we get 2,4,6 tribromophenol. Got it? Now the next reaction. Next reaction, that is nitration reaction. Halogenation, addition of halogen. Second reaction is nitration reaction. What happens in this nitration reaction? We will discuss. See. So next one, second reaction, that is nitration reaction. We all know nitration means introduction of nitro group. And how do we get this nitro group? What is the source of nitro group? Nitro group is basically obtained from HNO3, nitric acid. But what is the concentration of nitric acid? Accordingly, we get again two different products when we do nitration of phenol. See, so addition of NO2 group, it depends upon concentration of nitric acid. Concentration of nitric acid. So what are the concentrations? We can use dilute nitric acid. Dilute HNO3 if we use. Dilute HNO3 if we use. So it is mild condition and we get mixture of ortho and para-nitrophenol. And if we use nitrating mixture, what is nitrating mixture? Concentrated HNO3 and concentrated H2SO4. If we use this mixture, so as compared to this, quite stronger conditions are used in this case. So we get picric acid. Picric, yes, sounds funny, but nitro compounds are called as picric compounds. So it is known as picric acid. Okay, what's the product? I will write the reaction. So here, same like previous reaction, we have phenol. It is ortho-para-directing, reacts with HNO3. HNO3 I have splitted here as HONO2. So OH is negative, NO2 is positive. And all these reactions of benzene are nothing but electrophilic substitution reaction. H plus combines with this OH minus and replaced by NO2 plus. Means one electrophile is replaced by another electrophile. So we call it as electrophilic substitution reaction. Now see, if mild condition is used, then we get ortho and para substituted product. Orthonitrophenol, and another product formed is para-nitrophenol. Okay, so orthonitrophenol, I will write it little up so it will be visible to you more clearly. See, so here we can use nitrating mixture. And what is that nitrating mixture? Concentrated HNO3 and concentrated H2SO4. So here we get the product as OH as it is and NO2 is attached to para position plus H2O plus H2O. Nitrating mixture. If we use dilute HNO3, okay, we get mixture of orthonitrophenol and paranitrophenol. Now, which is major? You will say paranitrophenol is major because two groups away from each other. But in this case, orthonitrophenol is major product. Remember, very important. This is only the example where ortho substituted benzene ring is major product. Otherwise, due to steric hindrance, it is always unstable. Then why is it major? It means it has stability. Why is it stable? OH and NO2, they get connected to each other through hydrogen. See, this OH, we can write it like this, and NO2, the split up is like this, double bond O and this O minus. This oxygen and this hydrogen can form bond with each other. Okay, so these two are connected to each other through hydrogen bond, and that's why this orthonitrophenol is major product. They have not mentioned this point in your textbook. In the old syllabus it was given that orthonitrophenol is major due to intermolecular hydrogen bonding. Intermolecular, within the molecule itself, and here we can observe this is intramolecular hydrogen bonding and this is intermolecular hydrogen bonding. Intramolecular, within the molecule itself. Yes, I'm sorry. And here this is showing intermolecular hydrogen bonding. Always I say intermolecular hydrogen bonding. Consider one beaker containing orthonitrophenol, paranitrophenol in it. If we try to remove one paranitrophenol, we can see a chain of paranitrophenol. Means this OH is connected to NO2, this NO2 is connected to next OH and so on. So we can observe the chain. So this shows intermolecular hydrogen bonding. Here hydrogen bonding is found within the molecule itself. So intramolecular hydrogen bonding is there in this orthonitrophenol, which gives extra stability to that compound, and that's why this is major, this is minor. So effect of dilute HNO3, phenol forms mixture of ortho and paranitrophenol. Now what if we use nitrating mixture? See, benzene ring, it is attached, benzene ring connected to OH group, reacts with HONO2, it is concentrated, it reacts with concentrated H2SO4. In 11th we studied these two acids, they react with each other and they produce NO2 group. So source of NO2. So we call this as nitrating mixture. And the product formed. Again, strong conditions are there. So all positions get activated, and like previous case, substitution takes place at both ortho and one para position. So again, this is carbon number 1, 2, 3, 4, 5 and 6. So at second, fourth and sixth position, NO2 groups are there. So it is also called as 2,4,6 trinitrophenol, or we call this as picric acid. Picric acid. Picric compound. Compound having NO2 group are always called as picric compound. So this is picric acid. Okay. Many times they ask question, how will you convert phenol to picric acid? So picric acid means 2,4,6 trinitrophenol. Is this clear? So nitration of phenol is carried out by using either dilute HNO3 or by using nitrating mixture. If we use dilute HNO3, then we get mixture of orthonitrophenol and paranitrophenol, out of which orthonitrophenol is major due to hydrogen bonding. And when we use nitrating mixture means mixture of concentrated HNO3 and concentrated H2SO4, then we get 2,4,6 trinitrophenol. This is second reaction of phenol, that is nitration. Now we will discuss third reaction. Okay, and third reaction is sulfonation reaction. as the name suggests, sulfonation, that is introduction of sulfonic acid. Yes. What's the formula of sulfonic acid? Yes, it is SO3H. So it is third reaction. Sulfonation reaction. Sulfonation means introduction of SO3H group. SO3H group were to introduce in the benzene ring. Now product formed in this case depends upon temperature. One very important thing, dilute HNO, dilute H2SO4 doesn't react with phenol. Concentrated H2SO4 reacts with phenol. So phenol plus dilute H2SO4, no reaction. Phenol plus concentrated H2SO4, yes, we get something. What's the product? It depends upon temperature. So two temperature conditions they have given. One is room temperature, or temperature mentioned in your book, it is 293 Kelvin. In the old syllabus, the temperature was 298 Kelvin, 25 degree Celsius. Here they have considered 23, I think so, degree Celsius, okay. 20 degrees Celsius, 20 degrees Celsius, okay. Room temperature, okay. Don't get confused due to this numeric value of temperature. Room temperature. And other one is higher temperature, that is 373 Kelvin, higher temperature. If we use lower temperature, then we get ortho substituted benzene ring, phenol. And if we use higher temperature, then we get para substituted phenol. See, here we don't get 246. Remember this. Here we don't get 246. So, what's the reaction? Phenol. Phenol reacts with concentrated H2SO4, HOSO3H. We have splitted this. This is concentrated H2SO4. Okay. Reaction takes place at 293 Kelvin. If you don't remember this temperature, write room temperature. The product formed in the reaction. This H and this OH. Here one ortho hydrogen is there. H and OH, they combine to form water, and this H is replaced by SO3H. So product formed in the reaction is benzene ring, this OH as it is, and here SO3H plus H2O. What is its name? Ortho, at ortho position. Phenol, benzene, orthophenol, not benzene, orthophenol sulfonic acid. This is phenol, and its ortho position there is sulfonic acid group. So it is named as orthophenol sulfonic acid. Bit different name, sulfonic acid. Okay. Ortho position has SO3H. And whose ortho position? Phenol's ortho position. So it is called as orthophenol sulfonic acid. And what if we use higher temperature? Higher temperature. So phenol reacts with HOSO3H, of course concentrated H2SO4 at 373 Kelvin. The product formed in the reaction. Product formed in the reaction is this OH as it is, and here SO3H plus H2O. Okay, so this product is called as paraphenol sulfonic acid. Here we don't get 246 tri-substituted phenol because SO3H is very bulky group. So if we attach it here, here that OH is there, and one more SO3H here, so a lot of steric hindrance will be there. So such product is not obtained. We get orthophenol sulfonic acid and paraphenol sulfonic acid depending upon temperature condition. Is this clear? These three reactions, similar reaction. So I will tell you these three reactions one more time. We will summarize in short these three reactions, then further reactions we will discuss. Okay. See what happened in this reaction. Phenol is treated with HNO3, okay, nitration, or we can say here nitration, okay, nitration. Nitration product depends upon concentration of that acid. If we use dilute nitric acid, then we get ortho and para product. And if we use concentrated nitric acid along with concentrated H2SO4, then we get 2,4,6 trinitrophenol. Okay, I wrote nitration first. First reaction was bromination. Okay, now I will write here that as number 2. Bromination reaction. Bromination depends upon solvent polarity. Polarity of solvent. So less polar solvent. Less polar solvent gives us ortho and para. And more polar solvent in presence of water, polar solvent, we get 2,4,6 tribromophenol. 2,4,6 tribromophenol. And third reaction is sulfonation. Sulfonation product depends upon temperature condition. If it is 293 Kelvin, that is room temperature, we get orthophenol sulfonic acid. And if it is carried out at 373 Kelvin, we get paraphenol sulfonic acid. Paraphenol sulfonic acid. Paraphenol sulfonic acid. Is this clear? Very, very important. It's a summary of these 3 reactions, whatever I have explained now. Okay, see. One more time I will tell you. Nitration depends upon concentration of nitric acid. If it is dilute nitric acid, we get ortho and para substituted phenol. If we use concentrated nitric acid along with concentrated H2SO4, we get 2,4,6 trinitrophenol. Bromination, product form depends upon polarity of the solvent. If less polar solvent, we get ortho and para substituted phenol, and if we use more polar solvent, we get 2,4,6 tribromophenol. And sulfonation, it depends upon temperature. At lower temperature or at room temperature 293 Kelvin, we get orthophenol sulfonic acid, and at higher temperature we get paraphenol sulfonic acid. So today we have discussed 3 reactions of phenol, namely bromination, nitration, sulfonation. Remaining reactions we will discuss in the next lecture. Okay.